Okay. So we're just going to go back over the stuff I did in class and then move on to the next final. If you guys have any specific questions about the class, raise your hand and ask me. Otherwise, continue talking about Warcraft. It's fine. Okay. So explain the different product. Explain how product differentiation softens price competition and raises profits. Do you guys remember what we said about this on Wednesday?
Because they like move farther apart, right?
Yeah.
And so it's like the same thing as like location differentiation.
Yeah.
But you're just like moving farther apart with like your different product offerings, and so you can charge a higher price because they're different products.
Yeah. Exactly. So an example would be like cornflakes and frosted cornflakes.
What?
An example would be like cornflakes and frosted
And
cornflakes.
they differentiated on the fact that they now have like sugar.
Yeah, one has. No, with more sugar.
Yeah.
The specific answer he gave, price or product differentiation reduces the incentive to undercut or overproduce in the Cornell model, because small changes in price do produce large changes in quantity demanded. For trend price competition, the two-thirds of small change in price yields a doubling of sales. Not true product differentiation.
In a two firm, right?
Yeah, for two firms.
It'd be like a tripling.
With more firms, you have different changes.
It's just like an n. It's the factor of n, right?
Define the Herfindahl-Hirschman index. Explain how it might be used to determine the effects of a merger.
It's it's the shares of all the individual companies squared. It's the sum of all the squared shares.
Measures like the concentration of the industry.
Yeah.
And
So
then
higher HHI receives more intense scrutiny. Large changes in HHI also.
Can we put the questions on the board?
Yeah.
Sorry.
also, well, could we just like bring them up on the projector?
I can.
Did you post it online?
It's like below 1500 is not concentrated. 1500 to 2500 is like moderately concentrated. 2500 and above is very concentrated. I think. Don't like put my name on that on your stats, but I looked it up yesterday when I read my paper, and so
Yeah, seriously. When I started yesterday morning.
Also from like Wikipedia, so you need to go back and look at the site.
Brian, I really hope you're right, and he's gonna like look through my paper and find an HHI and then 3 sources and be like, sweet, 100%.
That's pretty much what you did for mine. So. That's good.
I just stapled money to the side.
You're just like, it's like 5 blank pages with an HHI.
So the mathematical definition for HHI is this.
It's like the easiest econ. Oh, really? Is this on video and audio?
Yep. You guys are all going on YouTube, except I'm the only one that can be seen. Haha! I'm the best. That's the mathematical definition. Okay.
Recorded forever.
Forever.
Wait, does it? Anyone have a pen I can borrow?
I do.
Yes.
Good catch.
Wide receiver hands.
Don't keep it open. That's recorded too. Okay. This next one. Explain how price discrimination can increase welfare.
Probably not.
So what does it do? How can price discrimination?
You're like, and I was like, it's bad.
Yeah, so they'll basically eat up the deadweight loss that's being lost right now, right? So if we have our curve, right? If this is where the monopoly is producing, right? Where marginal cost equals marginal revenue, then we have our consumer surplus here and our producer surplus here, and then deadweight loss. So if now we can price discriminate, we can take all of this as producer surplus. Because now they just make profit on all of it. Every consumer is paying what they're willing to pay, and there's now no deadweight loss.
But then also if it's for training competition, it's all producer or consumer surplus, right? And there's no deadweight loss.
Yeah, that would work too. But we're a monopoly, and that's why we price discriminate.
Yeah.
Because if you're a Bertrand competitor,
You don't price discriminate. No, I was just
you're
I was
not
just thinking of,
incentivized to price discriminate.
no, totally no. I was just.
But
going
yeah,
welfare
that would be another way to look at it.
to maximize.
Another way
So
to-
we can just draw a graph in the test.
Sorry.
You can draw the graph to illustrate your point, but your point is that the monopoly would now get both consumer surplus and deadweight loss. So it would increase welfare because this deadweight loss would be added to the current welfare.
But then there's no more consumer surplus. All the welfare is producer surplus.
Not if we perfectly price discriminate, yeah. If it's imperfect price discrimination, there may be a possibility where we're charging this price until here and then we price discriminate. We
So
could
the
do
new
that.
producer surplus is the big triangle.
It's the whole triangle, which is 2 times monopoly profits.
What's
Because
it?
welfare is equal to this. CS plus PS.
Is an example of like charging a flat rate and then price distributing like below that rate.
Uh-huh.
That would be like for like movies, for example, like matinees. They charge people that are more price sensitive going to like matinees. Or like seniors get a discount. Just going.
Yeah, those are examples of imperfect price discrimination or two-price price discrimination.
Yeah, I was just also thinking of like college tuition
Uh-huh.
because they don't like. Yeah, there are people who are super rich who are like getting a lot of surplus.
It's kind of like what FAFSA does, right?
Yeah.
So they're able to eat up a little bit more of the welfare. So we increase our welfare by having things like FAFSA or matinee tickets or things like that. So doing things like that is good. Having membership-only benefits like Amazon Prime is another example of increasing welfare, right?
Sounds
Could you explain that?
So with Amazon Prime, right, you get free movies and all these other things.
Uh-huh.
So they're price discriminating because they're going to charge you a certain price, and then they're able to offer you discounts on certain things. So they can charge you specific prices for every extra item that you buy. Right? You buy their membership, and then they're getting specific amounts of every item you buy for them.
Mm.
So it increases welfare because they get more out of it.
Mm. Oh, because okay, it's producer gets more.
It's not consumer surplus, no. No,
We don't want that. That
that's
sucks.
not what we're about. Okay, let's see. Define vertical integration.
No, stay.
T-shirt IO. It's for your own benefit.
Oh wait, you deleted it. You deleted it.
I deleted it. Yeah, it's gone. You better
Shut up.
write quickly. Okay,
I was trying to learn.
we'll learn faster. Define vertical integration. I'm lazy about writing, so let's go. And explain how a vertical merger might affect welfare. So what is vertical integration? Walmart and Target.
vertical integration is like.
Oh, here's a target.
It'd be like Kroger Foods buying a farm. That's vertical integration, right? It's buying up your supply chain. You're not buying out other
Do we talk?
people. You're buying up and down your supply chain. Supply chain. Buying stuff in your supply chain.
Not totally, but
We didn't cover
do a
this.
model. Where did we use
Vertical
it?
merger is the merger of a firm with its input supplier, right?
We discussed it,
So it's a car company buying a tire company.
which would then it the effects just lower costs then, right?
Yeah,
Of
it-
inputs
For
for the
actually lower
for the
costs.
car company,
For the
not
car
for the
company.
not for the tire company.
Yeah, unless you then buy your rubber production plant,
Yeah.
and then you buy, wherever the natural resources come
Did
from.
we
Then
develop
you're-
a model for that, or did we just discuss it as like an idea?
We discussed it as an idea, but we didn't go deeply into it. So I doubt you'd be asked to explain more than that.
Okay.
Vertical integration is where you're buying up and down your supply chain.
Cool.
And horizontal mergers are where you're buying another firm that does the same thing. That's Walmart and Target.
Unless, oh yeah, never mind.
Unless what?
Never mind. I was thinking of like vertical product differentiation, where like Target probably sells like higher end stuff than Walmart does.
Yeah, so
But
that would
people
be
go for the
vertical
target.
product
Yeah,
differentiation.
that's what I was.
Yeah.
The vertical is what caught me up.
So you just have to separate those two notions. If it's vertical product differentiation, it's the quality of the product, and if it's vertical integration, it's the supply chain
Yeah.
of the product. So yeah, what it would do to welfare is you're lowering costs because now you're not paying the markup in both cases. You're only paying one markup.
That makes sense.
Explain how collusion can be sustained in a repeated game.
Have an incentive to increase their expected profits times the contribution rate is higher than
So yeah, their expected collusive profits
Yeah.
are higher than their future profits. Yeah, exactly. And
Wait, expected inclusive profits are higher than their
so
monopoly profits.
it's basically writing this thing up.
It's just the incentive of colluding is greater than
Yeah,
the incentive. Yeah,
is you're saying it's greater than or equal to
the monopoly profits
deviation
now.
profits plus delta times Nash equilibrium profits times 1 minus delta.
Yeah.
Because we don't talk about penal codes, we just assume Nash reversion. Otherwise,
Oh.
if there were penal codes, it'd be different profits.
But if Nash is if it's a Bertrand, right?
So
then
if
it'd
it's
be
Bertrand,
zero,
this would be 0. If it's Cournot, it'll be some value,
some value.
which makes collusion harder to sustain for Cournot.
Or Cornell. Oh yeah,
Bertrand.
yeah, because they can still get payoffs in Cornell.
They can be like, well, if I cheat now, then it doesn't matter. I'll still get money. Okay.
Real quick, what was the second part of D? I didn't catch that. Like, how does it affect? How does vertical integration affect welfare?
How does vertical well, because it lowers costs, right? So instead of paying the markup that the tire company pays for rubber, and then the markup that the tire company charges the car company, they're just paying the markup the tires company markup or the rubber company's markup to get the rubber for the tire, and then the tire to the car company is they're within the same company, so they basically pay
It
cost.
makes the triangle bigger by lowering the cost.
I'm wondering why we have so many people confused. We're in this right. Okay. Make sure that I'm in the right place.
A lot of people blocked it because 3108.
Dang it. That might be the case.
Olympus question? Oh, okay.
I agree with you.
Dude, you can post it.
Room reservation.
I'm way down at the bottom now. Hey, Foley or not, keep an eye out.
3106. It's ours. I'm not crazy.
No. Can you see where you are?
But they're getting loud. So.
Yeah, if you attack, you can see where you're attacking.
Yeah, someone want to jump up and shut the door.
So you can. When I'm losing and running away, I should never attack. I just move.
Okay. What was I in the middle of? We were talking about collusion.
Oh no, I'm not worried about it, dude. Don't worry about it.
Oh, okay. So you can also, you guys remember trigger strategies, right? That's what I'm talking about. The trigger strategies are basically the Nash version. You play collude until someone cheats, and then you go down. Firm cheat until firm cheats, then all firms
The
revert to
answers give you the answers.
So, yeah, trigger strategies. We use trigger strategies that induce,
A lot of
or we use grim trigger strategies that induce a Nash version. But yeah, as long as you can explain. Explain why the first mover in a sequential move game might have an advantage. You guys remember what we talked about on Wednesday?
Sorry, say that again.
Why the first mover in a sequential move game has the advantage. What's an example of a sequential move game?
Like the prisoner's dilemma.
Yeah, you could say prisoner's dilemma.
Isn't that normally simultaneous?
But
It's normally simultaneous, but what if there's a first mover? What if one of
they
the
just
people
know their payouts?
Yeah.
Right.
Yeah.
And so they can choose which one they like, whichever side they choose. They know what.
Yeah, they force the Nash equilibrium.
Yeah.
Basically. Okay. Any other games or models that we use that have first movers.
Poisoning the king one that we always talked about.
Poison the king could be one. So the king, if he hires first, then they're never going to poison,
Yeah.
right? If he doesn't hire first, then they will poison.
Yeah.
So that it could be an a first mover advantage.
But I guess
It
Is-
means
is
that
the-
the king
is-
can pay lower wages, right? If he's a first mover and he hires someone because he knows they're
they're
not.
not gonna. Oh, that's true. Yeah.
So he can just pay, here's $1 to be my taste tester because no one's gonna poison me.
Yeah, and no one's gonna poison you either, so you could. That makes sense.
Exactly.
Or you can pay like just the going wage, right? Because it has to
Exactly.
be more. Or
First mover can manipulate the optimal choice of the follower, as in the Stackelberg game. Not always an advantage to go first, though. Not always an advantage to go first. Stackelberg works because the follower's reaction function is downward sloping. So there are disadvantages to going first in some things too, right? Like if you have the
if it's a Bertrand competition, you move first and you fix your price, so they can just fix the price lower than you or something like that, right?
well, they'll fix. I mean, because you're gonna fix. If you move first in Bertrand, you're gonna fix your price at marginal cost, so they can't
Oh.
beat you.
That's true.
I'm trying to think of a good example of a game where it doesn't work. I'll come back to that. There are
So-
games. There is
So
such a game.
why is it advantageous then?
So think of Stackelberg, right? If you move in Stackelberg, you produce more quantity, so you get higher profits. So that's the advantage of it.
Bring it up. Ask him.
Okay.
Speak up.
Explain why concentrated industries might be expected to have higher than average levels of profit.
So what was the question?
Explain why concentrated industries might have higher than average levels of profit. You're the closest to the mic,
I
so the
know.
more you talk, the
I
more
know.
they hear
I'm getting
your
embarrassed with the
conversation.
microphone, but I don't care.
Possible collusion,
Easier
yeah.
to collude,
There you go.
easier to-
It'll be less similar. Yeah, it'll be easier to collude. That's the main thing, right? Because you're going to move to competition as it becomes less concentrated, right? So the number of firms is increasing as it becomes less concentrated. His answer was, we have seen fewer firms, means higher prices and profits, lower welfare. Collusion is easier to sustain when N is smaller. Breaking up a firm may increase costs. Yeah. So say firms are currently producing at the lowest possible costs, but if you break it up, it'll increase their costs. Let's say fixed costs are at a certain level, right? Then you're gonna want to not break it up if you're the government. But the government's stupid.
Hey, you're being recorded.
You just got.
I am being recorded, and I believe these things. At least I'm not going off on like the economics that I actually subscribe to. Because I'm very
Now I
much
kind of want to know.
I'm very much a grid economist. I think we should, I basically believe in a second coming type event where those that are economically unviable to sustain life should be cold, and the world should go up. Yeah, that's what I think.
That's awesome.
Because we're not living as like at a sustainable level right now, unless like people either have to be more willing to collude so we have better deltas, right? Or we have to be more future oriented, or we just have to cull off the people that aren't willing to.
That's pretty awesome.
Yeah.
Pretty intense though.
Yeah, I'm very intense.
Brian,
Okay.
we're never gonna vote for you.
That's okay. If I do run for president, I've got a buddy who is very, very much a middle of the road, do whatever people tell him to do kind of guy. We've actually talked about this. So 2036, get ready. Tashima Anderson, 2036.
Shima Anderson.
Tashima Anderson.
Wait, wouldn't it be Anderson Shima? Is he gonna be your vice, or you gonna be vice?
No, I'm gonna be vice
Oh.
because I'll actually make the policy stuff, but he'll be the.
he'll be the
So
he'll
people
be the
elect
middle of the
him.
road guy that people like.
So it's exactly like Trump and Pence, right? Pence is the guy that's actually making the
Trump's the
decisions,
figurehead
Trump
that
is
no
the
one
face.
likes.
Yeah, exactly.
I don't know why you choose him to be
It's the
figurehead.
same with Bush and Cheney. That's what, so I chose to be the vice president. all the power with none of the pressure. Anyways,
But all the means.
all the means, all the power, none of the pressure.
Go in this class and then download
The
this
means.
video.
The Biden. The Biden.
Mr. Vice President says he wants to cool
I'm going to initiate the purge in the United States.
Delete this. You gotta delete this quick.
I mean, if you learn your rookies, then you can say whatever you want on recording. It's still elected, so.
It's true.
That's hilarious. Future
Anyways,
president.
no, I mean, when it comes down to it, like, no economist can force anything to happen. Like, you can try and incentivize whatever you want, and people just work around incentives. They're like, screw incentives, I'm not rational. Okay. So the very basis of neoclassical economics is like we're all rationally bounded, right? We all have rationally expected outcomes and things. Yeah, it's the worst assumption you can make.
But only economists are rational.
Well, that's the other worst assumption.
Irrational
Is
is
that
like
you were the only
irrational
rational person in the room.
Like, that doesn't make the model work. We assume that doesn't exist.
Yeah, we assume away humanity and expect to explain it. Anyways, the next question is: monopolies are popularly characterized as being lazy about R&D. When will this be true? When will this be false? Explain.
When there's no threat of entry,
Uh-huh.
then they'll be really lazy about it because they don't care. But if there's like threats of entry, then they'll be like, we better innovate before someone else does.
Yeah, basically lower their costs to a point where anyone coming in can't make profits. So they're going to innovate away profits for other firms. Innovate.
So create their own barriers to entry. But like, what's an example of one that would be lazy because there's high barriers to entry? Would it be like businesses that have like?
So think about energy right now. Like, do you see oil companies really innovating in the United States? Like, we're doing fracking now, which is like an innovation, but it's like things that people were doing 40 years ago.
Yeah. So it's
Other
companies with like high like fixed entry costs.
Yeah. So think about
capital investments.
think about like retail stores.
Yeah.
Like the proliferation of retail stores in the United States, right?
Yeah.
And strip malls and things like that.
Yeah, but then like, I guess, but they're being like disrupted by like online sales.
Exactly. So like Walmart was initially a very disruptive and very innovative, and then they got really complacent, and then Amazon came around.
Yeah.
Right.
So that's the thing is they like felt like there was high capital costs of entry and they innovated a bunch, but then they were like lazy because they like perceived high barriers to entry instead of like creating them themselves.
Yeah. So they were the most vertically integrated of any of the retail stores. That's why Sam Walton was a genius because he was so good at vertically integrating and getting the prices.
The distribution models, yeah.
But then Amazon came in and they're like, ha! We're better than you. Okay. Derive the learner index for the optimal price. This is one that I have to do on the board because reasons. Okay, so then we're going to start with the normal learner index. And then we'll also do the Dorfman-Steiner condition. I'm going to take off these shoes because I got a little more. Promise my feet don't stink that bad, but if they do, tell me. And then the video people will know too. Okay. What's my first step?
Derivative with respect to P.
Derivatives. Okay.
Derive with respect to P.
Derive with respect to P.
I feel like P because then that gives you the derivative of Q with respect to P as well.
Yeah, it should be. So we'll get Q of P. No, that won't be right.
Is it with respect to Q?
Yeah, it should be with respect to Q.
Okay. Oh, because is elasticity the derivative of price over? No, I don't know. Is elasticity the derivative of price over quantity as with respect to quantity or reverse?
Because what we want to have, right, we take this and we get
Oh, okay.
P to Q, right, times Q minus or plus P of Q minus C prime of Q.
And then you divide by your multiply times, or divide by P.
And we get P minus MC equals
dp over
negative dp dq q divided by p. Since we know dq dp is p over q
is elasticity. Yeah.
is elasticity. Well, that's price elasticity, right? This right here will be 1 over the inverse elasticity.
What do you do like? Now, why is it that you can just like invert dp dq? That's so weird to me. That it's like dp dq is the inverse of dq dp, even though is it essentially derivative of p as a function of q? Oh, but then it's just the derivative of q as a function of p. Then
Yeah.
it's the inverse of that.
Yeah.
So you just
So-
invert.
so-
I guess you just
so
invert
this-
the equation. Yeah.
Right.
Never mind.
P
That's fine.
prime makes sense to you, right? And 1 over p prime makes sense to you.
Yeah.
Those both make sense as expressions.
Yeah. Yeah.
So it's the same thing as writing, and this is the same as writing 1 over dp dq.
Yeah, but it's just weird to me that you can flip them. But I guess essentially,
Yeah.
it's like solving the equation for q as like your right hand side variable and then taking the derivative.
Yeah,
right?
it's like what you do when you're separating them. Like you separate your variables to do the integrals, right? Like you have x dy or something is equal to 1, right? When you get something like this, in like diffq, have you taken diffq?
No.
Well, even Calc 2 would have it. You multiply both sides by dy, and so you have x dx equals 1 dy. And then you integrate both of them.
An integral, yeah.
And just allow you can separate your variables this way. So it's possible. There's if you take theory of analysis and or abstract algebra, where you understand ring mechanics and things like that, then you can start like really understanding why we can do it, but just understand that we can do it.
Okay.
Can you see the board pretty well in the video? I'm trying
Yeah.
to decide if I should take notes.
Well, yeah, you can see it relatively well. But writing things down is always useful. What? Jeez.
You should put a sign that's like general review. Come on in. It's like a general review for all class.
General review. Finals review.
Finals review.
Okay, so we have this, right? Now, to do the Dorfman-Steiner, we write the equation the other way. Now we have Q as a function of P and A, but we still get to the same place. So I'm going to show you the way that you do it with Dorfman-Steiner.
What was Dorfman-Steiner? That was
Dorfman-Steiner it relates the price elasticity to advertising elasticity,
I gotcha.
or inverse price elasticity to advertising elasticity.
No, I got it. We're good. I got it.
Okay. This is equal to P times Q P and A
Today that we're playing, by the way.
minus
Yeah, never mind.
C of
It's
Q
not dumb.
which is of P and A minus A. Right? Does this look familiar to everyone? Dorfman-Steiner?
That looks familiar.
Marginal cost, fixed costs.
Yes.
Right. Take the derivative with respect to P.
I'm going to be dq dp. Oh. Oh, never mind. You're right.
Let's see.
It'd be dc dq dq dp.
Yeah. But I'm lazy about writing that all out, and then this is nothing equals 0. Right? So note that we have price and marginal cost. Right? So we're going to move our Q to the other side. So we'll get price minus marginal cost. Right? Equals negative Q. Now, if we divide both sides by P, we're almost there.
We just now need to flip this to the other side. So we can either divide by 1 over dq/dp and do that, or we can just flip it. Times dp/dq. Right? So we get p minus mc over p equals 1 over the negative price elasticity.
Those are all partial derivatives, right? Except the full derivative of pi with respect to p.
Yeah.
What does the Dorfman-Steiner tell us?
Dorfman-Steiner tells us this. So that we're not done yet. So Dorfman-Steiner relates advertising elasticity. So the change in profits given change in profits for advertising over the change in profits for price. The inverse change in profits for price is equal to just advertising over your total revenue. Right? So it's just it's kind of just a measure of how effective advertising is. Or not how effective it is, but what an increase in advertising will do
To revenue.
to your profits.
So and you just skipped a step. You just pulled out. You pulled out dq/dp from price and marginal cost, and then you divided by p on both sides in that same step, right?
Yes.
Okay.
Right here. Yeah.
Yep.
Yeah. Okay. Let's do the second part to find our epsilon a. So we're going to take the derivative of profits with respect to advertising. And we'll get, let's see,
What did you say to it?
minus
A
minus 1, 0. Price minus marginal cost times dq dA is 1 divided by p multiplied by dA dq. We're going to divide by something, actually, the next step. Okay, so we have p minus mc over p equals 1 over p. And this is all multiplied by dq dA. Now we're going to multiply this by 1 over dq dA. So we'll get 1 over dq dA here. I'm going to go right here in the middle. So we've got this. Right? What do we need to do to turn this into an elasticity? What do we need to multiply by?
Well, 1 over a over q.
Yeah. Okay. So we multiply this by a over q. What else do we have to multiply by to make it so we haven't changed the equation or the expression?
Q over a.
Yeah, q over a.
Yeah.
Right?
Yeah.
So if we can split these two up, we now have 1 over p times q over a times 1 over our elasticity, right? And this is all equal to p minus mc over p. So since these two things are equal, we're going to now set these parts equal, right? We're going to set a over p times q times 1 over the advertising elasticity equal to 1 over the inverse price elasticity, or the inverse price elasticity. Not 1 over the inverse price elasticity. Now to get to the Dorfman-Steiner condition. What do we have to do? What if we multiply both sides by A? Right? Then we get to the Dorfman center. Make sense? Got there?
Yeah, sorry, I'm just writing it down.
No worries. This is likely to show up. So I would make sure you understand how we got there. I have not, I don't see it until Monday.
Just shoot us an email Monday with the test.
I get in
Send out one you
a
put
lot of trouble.
Dwarfman or learner, that's it. You could just have a code word. Because it's all being recorded.
If you guys can solve learner, you can solve a Dorfman.
You need to drive twice, right? You just drive with price and then.
Yeah. You just have to recognize the difference in setup. This one you have Q defined by P and A. The other one you have P defined by Q. But it's still P times Q minus costs times Q. So just memorize it and make sure you can do this.
Sorry, so we go from. I'm still like getting all the steps in my
No
head
worries.
down.
So you write out your profit function.
And we end up with the learner index equals 1 over P times 1 over dQdA, and you multiply it by Q over A and A over Q.
1 over Q over A.
Yeah. And then, well, technically it's Q over A times A over Q regardless, because if it's 1 over that, right? But, and then, okay.
It is. You're right. Absolutely. You're multiplying it by 1. You're multiplying by a unit, which is fine.
Multiply by 1. You multiply by 1.
Multiply by 1. Just remember that you define 1 as
That's
Q over A times A over Q. Okay.
Which then turns into 1 over Q over A minus A over Q.
Yeah, which then turns into this beautiful thing. So the other thing you can do is, like, if you forget how to do this, you step back and you separate it into the 2 pieces and you say, okay, let me find this piece, let me find this piece. And then you'll have your Dorfman center. Okay? You'll probably be, if you're asked to do the Dorfman center, you'll be given this condition. Now take this.
We know where to end up.
Yeah. He'll tell you where to end up, right?
That's good.
He'll tell you that the learner index is this. Right? So now all you have to do to show this is you have to show this, the derivative. You have to show that you know how to multiply the extra pieces in, like the P and the dq. And then you need to show this. And when you do the learner index, it's good to show that you know where this 1 over the elasticity comes. You know that elasticity is equal to
So you get
QDP.
So you get that. So from here you multiply by, 1 over Q over A and times A over Q, right?
Yeah.
Then you end up with A over PQ times 1 over the elasticity of advertising.
Yeah.
Equals learner index, which is 1 over negative the elasticity of price.
Yeah.
So you get elasticity of advertising over the negative elasticity of price equals A over A times PQ.
Yeah. A over PQ. Got it?
Yeah.
Good. Now you. Two firms producing homogeneous goods and marginal cost 5 compete in prices. So whenever you see compete in prices, which model are you using? Bertrand, yes. And you see compete in quantities simultaneously, which model?
Bruno.
Compete in quantities. Yes.
He wasn't gonna trick us.
I wasn't gonna trick you. No. As long as you know what each of those signals are, you can pretty much set up your equation, right? So if you know that it's competing in prices, what is the Nash equilibrium in prices? Yeah, marginal cost. Yeah, price equals marginal cost. Right? What if only one firm has a lower marginal cost? What's the Nash equilibrium?
Marginal cost minus epsilon.
Yeah. And that firm will take the market, right? Okay, what happens?
That's per trend, right?
That's per trend.
Uh-huh.
What happens if there are 3 firms? One firm has the lowest cost, the second firm has the second lowest cost, and the third firm is just exorbitantly high cost. What happens?
They'll compete at the second lowest
Yes.
cost.
Second lowest cost minus upside, because the lowest cost will take the market.
And the highest cost will just get nothing, and they'll charge their price, their marginal cost,
Yeah.
right?
So how many Nash equilibria are possible in that case?
Unlimited.
Unlimited. Yeah, there's infinite. Because the third firm can charge anything, and it won't affect the Nash. It won't change the Nash equilibrium.
Wouldn't the firm stop existing because they have
Ideally, but maybe they're a trust fund baby like me, and they can just pay whatever they want and produce whatever they want. You're right. I'm ruining the economy. Okay.
Brian, we love you.
Thank you. Marginal cost is 5, right? So suppose one of the firms has marginal cost 4.9. We already decided what Nash equilibrium was.
Mhm.
And there are 3 firms. Show that the obvious Nash is not unique. That means there's infinite Nash equilibrium.
How would you show that?
You say,
With just with words, right? You wouldn't need math or
yeah,
anything, right?
you wouldn't use math.
You would just say
You just
because they'd operate at the middle firm minus epsilon's marginal cost.
yeah, or there would be any 2 firms can be competing at the price, and the third firm can be competing at any price above the marginal cost. I mean, they wouldn't sell anything, but they can still do it.
Yeah. Because it only depends on what
Five,
the middle firm charges. Because if they decided to charge above marginal cost, then the other firm would just.
Well, it
Price.
wouldn't be a Nash equilibrium if there are 2 firms that have the same marginal cost.
No, totally. But I'm just saying because there's 3 firms with different costs,
If
and
they
the
had
middle
different
firm
costs, yeah.
could technically charge whatever they like. Could also charge below or above their marginal cost, but the lowest firm would always just charge epsilon below them, right?
Yeah. Yeah.
So the only firm that doesn't really matter is the highest firm, right?
Essentially, yeah.
Unless they charge like below the middle firm, but then.
But then they're just losing money and they're selling. Okay.
I'm just,
No. It's
just trying to make sense of it. Sorry.
You can. But they're no better off, so there's no change in the Nash equilibrium. If they're selling below marginal cost, they don't increase their profits.
Oh yeah, because Nash is no incentive to deviate.
And no unilateral incentive, no incentive to unilaterally deviate. Let's see. Consider an industry with identical firms in which market demand is this 50 minus 2q. Do you guys want me to do this one again? It's the same one for problem set 8 that we've done several times.
Which one is it? Sorry, what's the?
The problems
What's
that's
that?
for 7 and 8.
He didn't post them, no. If you really need the solutions for
That's
set 8.
right, he doesn't post the solutions.
Yeah, he generally doesn't post
Oh.
solutions.
No, it's okay.
Oh, that's the one where like, if it goes to 25,
It's non-drastic.
it's non-drastic, yeah, but it has to go like to 2 or whatever. Right?
Yeah, less than 2. It's the point at which the firm with the lowest cost
Just
becomes
do
a
it again.
monopoly. What?
Yeah,
Let's just do it.
yeah, that'd be helpful probably.
Okay. So our marginal
call.
cost is 26. So that's equal to our price. Plug this in. Define our quantity. So the market quantity is going to be 12, right? 24 minus 2q. 24 equals 2q. So 12.
Because there's 2 firms, is that why it's 2Q or what?
It's just the
Oh, that's just
Many identical firms, that's just the demand function.
Oh, that's total Q.
That gives us price. Yeah, it's total.
Yeah. Gotcha.
Now, if one firm has the lowest cost, they'll be able to charge 26 minus epsilon, and they'll take the entire market of 12 units.
Mhm.
Okay, I'm not crazy. Now, how low must C be for consumers to right? For them to get something from the surplus, right? So until the point that it's close enough. Until this point, right? Where our new monopoly price is lower than our C naught, the consumers won't gain anything, right?
Because the price will be lower.
Yeah,
It'll
because
be like marginally lower, but not.
yeah, they'll still just be they'll be charging this original price, right? Once the monopoly can take over and lower the price,
Yeah.
that's where it benefits consumers. So we set this equal to our consumers. We set this equal to marginal price, right? And solve for. We set our monopoly price equal to that.
And is that
solve.
monopoly price always true that it's A plus C over 2
Yes.
for monopoly?
Yes, always true.
And then quantity is A minus C over 2?
Yes. Always. As long as your function is A minus Q, P equals A minus Q.
Yeah, BQ, right?
If it, yeah. So if it is BQ, then there's a manipulation. Right?
Manipulation in what way? Sorry.
Isn't it over B squared?
Because but that would be that's when there's more than one firm, right? Because it's A minus BQ, but is that that's Cornell though?
Let me prove this.
But in this case, B equals 1, so it's monopoly, right? Isn't that the idea?
B isn't the number of firms.
Oh, never mind. But B equals 1, so it's. But isn't it 2BN squared or something like that? Right?
It'd be this manipulation.
But then B equals 1 in this case. Yeah. But but in this case B equals 1.
Yeah.
Sorry, I just like the formula on the sheet I feel like had a B on it somewhere.
Yeah, it did. And that's where it would be. Interesting.
Because I remember we talked about like the whole when it moves from like
Interesting. Anyways,
2 to 3 firms.
we're gonna continue with this. C1 equals 52 minus 50. So the inflection point is at C1 equals 2. Right? So we have to have this cost decrease all the way to 2, or a $24 decrease in cost.
Question, right?
What's up?
So price and monopoly is A plus C over 2,
Uh-huh.
and then quantity is going to be is it A minus C over 2,
Yeah.
and then profits is A minus C squared over 2.
Yeah, A minus C over 2 squared is profits. And so CS for a monopoly is also always this. It's half of your producer surplus. So if you can perfectly discriminate, you get 2 times your monopoly profits.
Was it going to be
No.
profit? Yeah, it's not
Monopoly profits, just that. Sorry, that's great.
Monopoly price is equal to the initial cost in this competition, right?
That's the inflection point. So that's where it changes, right? That's where it becomes a drastic innovation. That's why we're setting it equal to the monopoly price. Question?
So it becomes monopoly profit is A minus C squared over 2. Or A minus C squared, yeah, over 2B.
Yeah.
Because it'd be right if it's times.
No, it's just over 2. Right? Because you get minus A over 2 plus C over 2 minus C. Right? This is all times Q.
Yeah, and then Q is and then times B in there somewhere, right?
No, the B gets canceled out.
Oh, that'd be it, right? Sorry. Oh yeah, cool, awesome.
But if this were weird.
Is A minus C over 2 squared over B or something like that? 1 minus b, right? That's not the solution. So it's a minus b squared over 4b.
Yeah. Yep. That would be the general solution.
For monopoly.
Yeah. I'm wondering why his solution there doesn't include the 2q.
Where's that?
This, right? So this is our market demand,
Oh.
and b is equal to 2, but it's not included here. Weird. But we're going to live with that solution.
Yeah, that's fine. I'm happy with it.
Okay. Now suppose the initial market structure is monopoly. How low must C1 be for consumers to benefit from the innovation? Explain. All right. So if it's a monopoly, how much do monopolies pass on to their consumers when costs are reduced? Right. We have this. So if we do PDC, so the change in price over change in cost. Right? So they'll pass on some proportion of their cost savings and price reduction. So if cost decreases by 1, it'll be some 1 over 2b. Got it?
That
That was number C. Yeah. Letter C.
Will you explain that one more time? So price equals a plus c over 2b.
Now this is monopoly price. So if in a monopoly, at what point will they introduce cost savings to their consumers? Like, will prices lower with response to costs? So I'm going to take the derivative of price.
But isn't it just the C1 equals 2?
Costs.
That's the point that they'll start passing it on, right? Passing on savings.
Yeah.
So, but you're just proving that they do pass on savings.
Yeah. So if they start as a monopoly, any cost savings, any innovation will
Pass on
introduce savings.
But the idea is that we're solving for the point when they become a monopoly, right?
Yes.
Is when PM is less than C0.
And it's two separate questions. The questions worded in part C, they are just monopoly.
Yeah, they're just a monopoly.
Oh, so yeah. Oh, okay. Sorry. Yeah, it looks like this. Okay.
Yeah,
that makes sense.
Okay.
So it doesn't matter. It's just no matter where you start. If you decrease it all, then it passes on
Yeah,
cost savings.
they at least according to our model, they should pass it on.
Yeah.
Not that it necessarily happens in real life, but that's what should happen. Because monopolies. So I hope the big takeaway from this class is that monopolies are not evil. Monopolies are actually very good for many things. And oligopolies, like pure competition, is the opposite of capitalistic intent. Like, if you're in a market, you want to concentrate it so you can get the most possible out of it. Unless you're a social planner, and then you're stupid. But so I'm reading this book. It's called The Dictator's Handbook, and it talks about the ways that you basically take and maintain power, right? But it shows how both autocrats and democrats do it. Like, autocrats do it by basically bankrolling their advisors, their closest people, like making the smallest coalition, like killing off anyone that can oppose them, basically, and then paying them off, the people that are left. And then in a democracy, you get the most from benefiting your consumers. That's why gerrymandering is so bad, right? So you try and make the biggest possible districts for your constituency and give them back what they need. But now, like, you'll give vouchers and handouts and things to the people that support you, but not to anyone that doesn't support you. And that's how you maintain power in a democracy. Anyways, really good. That's why I think we should do away with government.
What?
Because of reasons. Okay, so you guys want me to go over number 5, which is the monopolist operates in a market with inverse demand? This one? The advertising? Okay, sure. The advertising question.
Next year.
Equals 120 minus Q plus A is the 1/2. Minus A, because Larry's crazy and he doesn't have to pay marginal costs. We take the derivative with respect to Q. It's times.
Isn't it 100 minus Q though?
Your mom. Oh, number 5. I'm on number 6.
See, yeah.
Okay. Q equals 45. Right? So P star equals 55. You guys got all this?
Yeah, it's Monopoly, right?
Yeah.
Profits and crime.
Right, that's 100. That's 100. So this will be 45 times 45 over 2 CS.
Oh yeah.
PS equals 45 squared. Deadweight loss will be 45, and then this is that is 45 over 2. Right?
You're
CS,
solving the triangles.
CS, deadweight loss, PS, right? So where I got 45 squared, it's 55 minus 10 times 45, right? That's the lines. This one you can solve by setting.
Wait, 55 minus 10 to solve consumer surplus? Oh, no, just solve, sorry.
Producer surplus.
Producer surplus, sorry.
Producer surplus, right? Yeah, so this is 100 minus 55, which is 45, times 45 squared.
Over 2, yeah.
Yeah. And then this one, you can do this by setting, right? You set marginal cost equal to the price curve. So we're trying to find what this quantity is, right? So we have 100 minus.
So essentially, though, if like it's a linear function of Q, then deadweight loss and consumer surplus are always just 1/2 your producer surplus.
Yeah. This whole area is going to be 2 times the producer surplus for a monopoly.
Wait,
If it's like
isn't the base of your deadweight loss triangle 55 or 45?
oh, that's true.
No.
Shouldn't.
Yeah, it's 100
No,
minus
'cause it's
45.
minus 10. You're doing it from the cost.
From
So
cost,
cost
where
equals
cost
10.
equals
So
10.
55 minus 10.
Oh,
Yeah, 55 minus 10, so it's 45.
You're not going all the way
the
down to the
base of your deadweight. Yeah, that isn't that.
it's what?
So it's 45 to whatever this point is. This point's 90.
How do you know that?
Yes.
Okay. Sorry.
Q equals 90. At the point where marginal cost equals price,
Oh, yeah, okay.
it's 90. Geometry. Because geometry. Thank you, Descartes. And Euclid. And all those people. Okay, number 6.
Descartes was a geometrician.
So you know the Cartesian coordinate system?
Oh, yeah, Cartesian,
You know this whole thing where we go like this?
yeah.
And we have y and
Isn't the
x.
same guy that was like, I think therefore I am.
Well, he didn't actually say that. He said cogito ergo sum, which is the Latin. But yeah.
Yeah, well, that's. I translated it. Come on.
Your
I know the Latin.
Your translation is invalid. Yeah, so same guy. He also did, like, he started setting up the basis for calculus. But he was like, he said the problems were too hard, so he just stopped doing it.
Really?
Yeah.
That's cool.
The reason why we have a
Very easy guy.
Cartesian system is because he was trying to do calculus. He's like, well, I can't do it, so then Newton's like, calculus. Okay. Anyways, Mathematics.
so much, dude.
Yeah, I've taken a lot of history and philosophy of this and that classes, so it's really easy to do it.
Come on in.
You can join us and learn history and philosophy of economics. No, actually, so if you guys still have classes to take left, I would recommend Dr. Lamson's History of Economic Thought course. Like, super easy course, and if you're really interested in like why economics and why we do the things we do, it's great. Okay. Advertising problem. You guys want me to do Crazy Larry or no?
Crazy Larry.
Do Crazy Larry? Okay, do it. This one's 120.
All of them, don't have
The Crazy Larry. The Crazy Larry.
Crazy Dalshon.
We gotta invent that dance move.
All us econ students, I'm sure, could come up with a pretty good dance move. Did you do this? Sounds like a white guy sign, right? Like a white guy just like doing the Crazy Larry.
20 minus
Also, it does sound like a murderer.
That could be her name.
A. Q equals 60 plus 1/2 radian.
it. Doesn't matter.
That's our Q star.
Probably like more like
Now, what is our optimal advertising level? 1/2 A to the negative 1/2 minus 1 equals 0
oh my gosh.
times Q. Sorry, I just forget that. So Q over 2 equals A to the 1/2. Great, plug it into this. 60 plus 1/4 Q equals Q. Q equals 40. Woo! So that means advertising equals what? 40 over 2 squared. Something. Something's wrong. No, it's 80. Sorry. 80. Okay. Now we're right. 6,400 divided by 4. 1,600. Okay. And his profits are 120 minus 80.
Before we go too much further, can you like kind of walk me through that? I think I'm still back
Skip, like,
on
a
like
lot of
step 2.
I didn't skip that many steps. This is
So
like,
like, okay, so we got Q star.
I want to find price level first.
Okay. Sounds good.
So did you solve for?
So for everything.
Did you solve for A first, or did you solve for Q first?
Q first.
Did you,
And then solve for A.
Okay, I solved
because
for
he
Q
said- he said
first.
A first.
I found the optimal,
You're solving them
I
simultaneously.
found the best response for Q
With
for some A,
And
right?
you plugged it back into the.
Yeah, so now, no, I haven't plugged it back in.
Oh.
I just now do this, right? So I take this derivative, right?
Hmm.
So A shows up A times Q, right? A to the 1/2 times Q. Derivative of A to the 1/2 is 1/2 A to the negative 1/2
Yeah.
times Q.
Okay.
And this is negative 1, so we get this.
Yeah.
Now, I did skip steps here, you're right. Now I multiply,
over.
divide by Q, I move the 1 over, divide by Q, multiply by 2, and since this is to the negative 1/2, I flip the equation and get it to the positive 1/2.
Okay. So you
Right.
converted it.
So I do this, I do
Essentially just
1 over 2 times A to the 1/2 times Q
so you just basically multiply
equals
by
1.
yeah.
Now I'm going to multiply by 2 over Q,
or just multiply by A to the 1/2.
or multiply by A to the 1/2.
So you didn't skip any steps except for moving the 1 over.
Whatever.
Well, he paused there. He stopped there and found Q star, and then he went over and solved for A. And then
So
plugged
you
it back
solve
in.
for A.
So yeah, now I've got A to the 1/2.
Back into
I plug the A to the 1/2 back in. Solve for Q. Plug the Q back in. Solve for A. Okay. Now I plug Q and A to the 1/2 in. That's it.
So, but is this kind of backwards induction? Because does he set advertising first and then gets Q as a response to the advertising?
Yes. Kind of backward induction.
Maybe, I don't know.
Yeah.
Like you're holding advertising
Think about it as backward induction.
Because he sets advertising and then he gets Q. But I guess advertising.
But his advertising is also based on his Q. So it's like kind of like
Six
mixed.
simultaneous.
It's
Simultaneous
just,
best
advertising
response
is just,
functions.
it's just your cost essentially, right? In this.
Basically.
Yeah.
Okay. So then now I plug those back into my price function. And I get prices, optimal prices equal to 80. So now we get this to find our profits. Right? Profits are equal to so we get 80 times 80 minus 80. So we get 79 80s. What is this? Would be
60 to 120.
63.
Right, because it'd be 6400 minus 80.
Yeah. Yeah. Sorry, I'm doing something. Okay, yeah.
Advertising 1600.
Yep, 6320 would be the level of profits.
The advertising 1600.
It's
You're
it's
right.
essentially 80
It's
times
4800.
minus 80, so we pull that an 80, and then it's 80 times 79, or 80 minus 1.
I'm wrong. 40 squared. So it's
Uh,
4800. We did this in class. I did the exact same thing on Wednesday.
Oh, you did it do like 2 40s instead of 40 squared.
Yeah, I did something where I made it 80 instead of 16. Okay. Yes, so don't do that. Actually use the level of advertising that we solved for. Don't just plug in 80s for everything. Okay.
6,400.
I suppose there's an ordinance against advertising, so that advertising equals 0. So basically now we're solving the monopoly thing. Right? So Q equals 60, price equals 60, profits equal 3,600. But no advertising, right? So what happens when we ban advertising? We lower profits, we lower quantity, we lower price, we lower advertising. So everything goes down.
Sorry, these are both first order conditions, right? Maximizing with respect to quantity and with respect to advertising.
Yeah, first
Because
order
it's not like a 2-stage kind of thing. It's
Well,
all-
it's 2-stage, but you're not taking a derivative of this.
you're not plugging it back in. Yeah.
No, yeah, you're not plugging into the first like in Stackelberg. It's not.
Yeah.
It's simultaneous action.
Yeah.
It's
So
not
that's what I'm saying.
sequential.
Simultaneous.
Yeah,
Whereas like
it's-
one of them might be if like we were talking about our Q in period 2 with respect to like advertising in period 1.
Yeah, then you do that would be backward induction.
Yeah. Where you get your optimal Q with a constant A and then plug it as a reaction
you'd find
back
you'd-
into your profit. And
Yeah,
then
you'd
take
find your optimal second period,
Yeah.
and you plug it back into your first period, and then solve for your first period.
Yeah.
Yeah, like Stackelberg.
It's not comprehensive.
It is comprehensive, but it's heavily weighted towards the end.
So we need to remember that for Stackelberg.
Yes, you will need to know how to do a Stackelberg.
What about like sequential games?
Like an ultimatum game?
Or like the sequential game we talked about where it was like you had the value of the the payout or whatever, and then with each period the payout was less.
Yeah, the ultimatum game.
Oh, that's the ultimate game.
Yeah.
Okay.
I'll do a brief Stackelberg. I'll finish this. And then we'll do a Stackelberg in the ultimatum game, and then I'll move on to the next one. So you guys have all the material.
Wait.
So we have 30 minutes left. We're done.
Yeah, whatever.
I don't think so.
So just when advertising is banned, everything goes down.
Everything goes down when advertising is banned. So advertising is good for a monopoly. Okay, you invent a new style of computer mouse and are deciding whether to patent it. Demand for the new mouse is this. Marginal cost of production is 60 per unit. There is one other firm capable of producing an exact copy of your mouse. Suppose it costs $1,000 in legal fees to file for a patent. You anticipate that without the patent, you and the other firm will set a collusive price to split the market equally. Do you file for the patent? Okay. So if you don't file for the patent, right, and you guys are going to be in Bertrand competition. So if you set a collusive price with one other unit or with one other competitor, are you going to file a patent, right? At what point would you be willing to file a patent?
If profits are less than 1,000 or less than the patent code.
Yes. All right, you want monopoly profits greater than 1,000? Greater than or equal to 1,000?
Monopoly divided by 2, right? Because you want your profits to be greater than the patent. Because you're splitting the monopoly profits between two firms.
If you have a patent though, then you are a monopoly, right?
Okay.
So if monopoly costs are less than 1,000, you won't file a patent.
Yeah. And
So what's the point at which you're going to do it? Right. But then you want collusive profits. Monopoly profits. Does that seem right?
So you'll patent it when monopoly profits are greater than 1,000, and you won't patent it when inclusive profits discounted are greater than monopoly max patent.
why do we only discount the collusive profits?
Okay. Yeah. Let me just do this real quick. Here's what the monopoly would look like, right? Yeah, so it'd be P minus 60 times 8.
So you just solving this right now?
Yeah, I'm solving for monopoly profits. Profits to P.
You're essentially taking either monopoly profits divided by 2 or monopoly profits minus 100 or minus 1,000.
This doesn't add up with what he's got.
Oh, never mind. Let's see.
Hey Brian,
What's up?
do you have answers on the practice test?
I do.
Are they on the learning suite as well?
No, I'm not supposed to give them out.
So, the inclusive price though. Did we talk?
Yeah, the inclusive profit is something higher. Trying to solve.
Isn't inclusive profit a Oh, but we'd have to. Isn't it 2, like a minus c squared over 2bn squared? Like, you remember when we talked about that in, look at my notes. Let me put a quiz or something.
Let me try this. 60 times 10 is 600, right?
Uh-huh.
There we go. Figuring.
It's like the whole thing of like.
Okay, this is 330. 600 minus.
It's the whole thing of like merging, right? Yeah, the profit of a monopoly profit is a minus c squared over 4b.
Right.
Hey, Brian.
What?
I think I just remember the general form for profits that might help with inclusive price. But
yeah, sure.
But isn't it a minus c squared over n plus 1 squared times b?
Yeah. So 2 firms, right?
That'd be 1. Yeah, so with 2 firms, then it would be over 9b, right?
Yeah.
So couldn't you just solve for p as a function of q in this scenario?
Well, you saw. Not quite. Let me finish this.
Okay, sorry, yeah, you do your thing. I'm just spitballing.
Okay, so these are the optimal monopoly price quantity, which gives us total profits of this. And then if you subtract off our patent costs, we'll get a total monopoly profit of 215. And to find the collusive price, it's going to be, yeah. Okay.
That's hilarious.
Yeah. And so then we do this. Anyways,
I think
it's going to be like 600 and something.
I think it's
It's over 600.
540. Right, because it would be 600, 600 minus 60 squared over b times 9, which would be 9 times 60, which is 540. So it's 540 squared over 540. Because it's b times n plus 1 squared.
Yeah.
Should be, yeah, over 540. So you just get 540.
Something wrong with it.
C has 607.5
Is the answer?
is the inclusive product.
So then that must not work in this case. But
It should.
okay. Give me 1 second.
So we're still part of that.
Yeah, we're still on part A.
Maybe he's wrong.
What?
I said maybe he's wrong, but I'm just teasing.
He's never wrong.
Probably never. He's a genius.
Yeah, I'm kind of confused as how he wants to set this up. Because I can get this, right? And I can get this just fine. I can find the monopoly price.
And I propose a solution. Let's email him. Get some more detail.
You guys are welcome to email him
Let's do 8.
about number 8. Now, for the second part, Bertrand competition, what happens, right? There's no profits.
Then it's, yeah.
So 215 is better than nothing, right? So if you know you can collude, it makes sense to collude. It seems like because you'll set a price, like you will set a price above monopoly profits. So or you'll set a price such that you get more than monopoly profits. Interesting.
So you do file?
You don't file if it's collusive. You do file if it's Bertrand, like if you will be competing on prices. Now, suppose you must also consider whether to file a patent in Britain, a market which has similar consumers but is about 1/6 the size of the U.S. market. Filing fees are $1,000 there as well. Would this likely change your answers to A and B above? So for part A, it would probably not be worth it. Part A, it's not worth it because inclusive profits would not be greater than your cost of filing in Britain. And in the second case, you're out over $700. So it's not worth it in either case if you're only getting 1/6 of the size of the market. What's up?
Sorry, how'd you get that 600 minus p in that first equation?
I multiply this by 60. Multiply my quantity by 60.
Oh, okay.
That's what I did. You could also do the same thing here. Like you leave it as this. Right, 10 minus 1 over 30 plus 1. So you'll get 11 is
So if you
equal-
multiplied quantity by 60 though, what else did you multiply by 60? Did you then multiply?
Yeah, I divided it again later when I was looking for it.
Oh, you did.
I made magic happen.
Cool. I like
That's what I
magic.
did.
Math magic.
Math magic. But the price is obviously this. That's
Okay. Number 8. Suppose a market has inverse demand, P equals 100 minus Q, and incumbent monopolist. Firm 1 moves first, choosing its output Q when the incumbent has cost function 40 QI. Potential entrant decides whether to enter or not. The total cost is 100 plus 40 Q2, where 100 is sunk cost paid upon entry. Suppose the entrant observes the incumbent producing output Q1 bar, then decides whether or not to enter. Finding the entrant's optimal output, assuming it enters its function Q1 bar.
So this is kind of like problem set 9 part or number 2. Yeah, I would email for clarification.
How'd you get rid of the p squared? You just erased it, but isn't there a p squared up there somewhere? Oh, you take the derivative. Sorry. Never mind. I'm losing my mind.
You kind of are. It's getting late. It's one of those days.
Getting late. Almost 3 p.m.
It's almost 3 p.m. It's time to go to sleep. So I do not envy anyone who has tests tomorrow. I'm so glad my first test is on Monday.
Okay.
So firm 2, we're just going to be looking at firm 2. They're facing this demand minus 40 Q2 minus 100. What about last one? Spencer's just stuck on problem 8 still. We're on number 9. Or we're on number 8. You're on 7 still.
Sorry, I'm just trying my best to.
I would give up on 7, not spend the mental energy, and email him. And then I will email him as well, and I will go over number 7 at 6:45 on Tuesday if you're really interested.
Whoa.
Somebody wants to be
In the morning?
Because the test starts at 7.
That's like really early.
6:45 is not that bad. I mean, I'm gonna be getting up at like 6 to go and get donuts and bring it to class. I will go over it again on Tuesday if you really care to be there. Otherwise, you can just sit there and eat donuts while we wait to start the test.
Is that a Q bar?
This is a Q1 bar, yeah, because it says as a function of Q1 bar. So we're gonna find. I wish this marker weren't dying on us. Sorry, video people, that the marker's dying on you. Good luck. May the odds be ever in your favor.
The odds be ever in your favor.
Yeah, I was just rewatching those movies the other day, and I like.
They're messed up, dude.
It's so messed
It's a
up.
bunch of kids murdering each other.
Like the thing is like it's based on this old Russian novel called We, right? 1984 and A Brave New World, and all those are based off an old Russian novel by what?
Why did you know this?
Because I love science fiction, and so I was reading about the great works in science fiction, and We was like one of the like primo dystopias. It was written in the 1920s, like before Hitler, like during Stalin's reign is when it was written. It wasn't published in Russian until the late 1930s. No, 1980s. No. Wait, yeah, 1980s. It was published in Czechoslovakia in the 1930s. Anyways. Yeah, weird stuff. Something like that. But yeah, so like the Hunger Games is based off like those old ones, which is based off this even older one. And it's just messed up. Like they literally like in the middle of these books just like chop people's heads off and vaporize them and put them in vacuum tubes until they like pass out and then revive them and put them back in vacuum tubes. It's like messed up stuff. Yeah, the dystopias, they were cool. This is what I do in my spare time, guys. Is read dystopias.
They're gnarly books. Like any Stephen King novel, right?
Yeah, I guess he's like the inheritor of the dystopian. Like he's a postmodernist in science fiction. But anyways, so
There's an elder mention.
there is our optimal Q2 as a function of Q1. So if they enter, that's what they'll do. Solve a limit that is just large enough to deter entry. So that means what will Q1 have to be so that profit for firm 2 equals 0, right? So that's 100 is equal to what we have left. 100 minus Q1 bar minus 30 minus 1/2 Q1 bar times, let's see, minus 40 times 30 minus 1/2 Q1 bar. Right? What? All right, move the 100 to the other side. Okay, so we'll get 30 minus 1/2 Q1 bar times 30 minus 1/2 Q1 bar, so that's squared equals 100. You'll get 10 is equal to 30 minus 1/2 Q1 bar. So you get Q1 bar is equal to 40. Right? You add Q1 to that side, subtract 10, and multiply by 2. So you get 20 times 2 is 40. Or alternately, we multiply everything by 2, and then add to one side and subtract to the other. Or we subtract from one side and multiply by -2. Regardless, we still get Q1 bar equals 40. So this was 1/2 of a Stackelberg. This right here is 1/2 of the Stackelberg. So I'll complete the Stackelberg so you can see it. So term 1 has this minus Q1 minus 30 plus 1/2 Q1 times Q2, or times Q1 minus 40 Q1. That's firm 1's profit function. So now we take the derivative. Minus 70, 30 minus Q1, right? Because we have negative Q1 squared, negative 1/2 Q1 squared. So we'll get minus Q1. So Q1 equals 30 for the Stackelberg. Now if we plug this back into what they have, they'll have Q2 equals 15. Sorry. Right?
So that top equation on the right, that's just algebra. You're just simplifying that, correct?
Yeah, that's just algebra. There's no derivatives or anything. You just simplify. You say if my profit equals 0, that's when I won't enter as the entrant. So what does Q1 have to be? You're solving for Q1. Now this way, so optimal Stackelberg, right, they'll underproduce to deter entrance. So if they wanted to deter entrance, they would have to recognize that and overproduce. Does that make sense?
So the Stackelberg, you take the follower, you differentiate from their optimal, and then plug it back into
the profit function.
The profit function for the other firm, and then differentiate.
Yeah.
And then take that and then plug it back into the second one to find their.
Yeah.
Okay.
Yeah.
So they'll want to overproduce if they want to keep from 2 out?
Yeah.
Okay.
So optimally, this is what would happen. But if we overproduced, right? If we did Q1 equals 40, right? So we get this is equal to 10, Q2 equals 10. Then we'll see if we plug that back in, right? We plug in 100 minus 40 minus 10 times 10 minus 40 times 10 minus 100, that equals 0, right? So we'll have 500 minus 400 minus 100, which is 0. So that's how it works. That's how all the math makes sense. Any questions on the Stackelberg? Okay.
So that's a general pattern for anything that has 2 stages, is that you solve, just do the whole backwards induction thing where you solve the second stage first and then plug that back into the first.
Yeah, that's what backward induction means.
So getting
No, it's, I mean, it's a valid question. Yeah.
This at all.
Yeah.
But understanding that shows up in Stackelberg, and what other models?
So the ultimatum game is where it shows up. You'll also see it. Where else have we seen it? Backward induction, like you can do it for multi-period advertising, multi-period monopoly. You kind of do backward induction, right? But like actual backward induction is pretty much the Stackelberg and the ultimatum game. Those are where we've done it in class. Okay, let's do the ultimatum game really quick. And I'll email him. If you guys have, so if you guys are going through the practice quiz that I emailed out to you and you have questions, email me and I'll help you answer them, or I'll give you answers for the questions that you need. Right?
Will you put the one you were going through right now on Learning Suite too?
The ultimatum game?
No, the practice.
Is it not on Learning Suite right now?
I don't think so.
Yeah, I said I was going to remind him in class today. I'll remind him to have, I don't have the original file, so I'll remind him through this. Put it on Learning Suite.
Was the answer 607.5?
Yes. How'd you
Okay.
find it?
Okay.
Which group?
Yeah. So you just take the quantity, and because they're splitting the market, you just take the quantity divided by 2.
Okay.
So I just divided the quantity by 2, and then I just solve for it. And so you solve for the price, and the collusive price is the same as the monopoly price. And then you just plug it back into the profit function.
So it's just much simpler then.
Yeah, we were making it to be too tough.
So you just take half the quantity times the
Yeah,
monopoly price.
Well, yeah.
You just use monopoly price. Okay.
No, well, so what I did is I solved for the price again, but it just happened to be the monopoly price.
Well, it makes sense that it's the monopoly price because you can't do better. Especially you're using half of the monopoly quantity for 2 friends, right?
Yeah.
So you're just
And then, but
dividing by 2 and then
You're dividing by 2 and then multiplying by 2.
Say that again. Sorry.
You're dividing by 2 and then multiplying 2 when you plug it back into the price, right? Because you're adding the quantities together to find the price. Because you use total quantity. Yeah, so you'll get the same price.
I just divided the quantity by 2 and I plugged it in the profit function and then solved for price.
Yeah, and so it makes sense that you set collusive profits to monopoly profits. Or you set collusive price to monopoly price.
Right. Yeah.
Because it's not per trend. Yeah.
Plus, it would just make sense that you take the total profit of 12.15 divided by 2, right, and then get 607.5.
Yeah.
And then
yeah, it would make a lot more sense that way.
Yeah, thinking about it that way.
That was easy. I wish I would have thought of that, but I'm not that smart.
I didn't think about it until we thought about it. Total profit was 12.15, right? And so you just divide it by 2 because they're splitting the market.
Because you couldn't do better in the market than monopoly profits, right?
Yeah.
So you just do a half of it. Okay, ultimatum game. That's what we're doing. So player 1 can offer anything between 1 and A, 1 and alpha, right? We'll do 0 and 1 just because.
So they offer some S, right?
Yeah, they'll offer some S, right? So if there's just one stage, player 1 comes away with 1 and player 2 comes away with 0, right?
Yeah. Or 0 and 0 if they reject, right?
Or 0 and 0 if they reject. Accept. And because they're no better off by rejecting, we'll just say they accept in the one stage game.
Unless they're like spiteful.
Unless they're spiteful.
But then they're better off rejecting, I guess.
Yeah. So now we have.
Oh, this is
right. So they can offer between 0 and 1. Player 1 does. Player 2 can accept or reject. Right? And if they accept in the 2-stage game, then they'll get some number and some other number, right? And if they reject, then player 1 now gets another chance. And this is player 2. Player 1 now gets another chance to accept or reject. And if they reject, then it's 0, 0. So player 2's, this is where we do backward deduction. Player 2 is going to offer them. They're going to offer them, and it decreases by delta. Right?
They're going to offer him 0, right?
They're going to offer them 0, and they're going to take delta.
Yeah.
And you can also write this with V's instead.
Yeah, let's do V, because I think V is what
That's
we did.
what we use, delta V.
Yeah.
Okay? So we're going to offer delta V, and we're going to get V minus delta V. Okay? So the way that we'd write this Nash equilibrium is we'd say player 1 offers 0 and player 2 accepts. That's the Nash equilibrium.
Mm-hmm.
So in this one, the way to write this by backward deduction, you say stage 2. Player 2 offers 0 and player 1 accepts. In stage 1, player 1 offers delta V and player 2 accepts.
Do you have to write the stage 2 part, or can you just draw out the game and then just say, because of backwards induction, player 1?
So if he asks you to show the backward induction, I would say if you just ask for the Nash equilibrium, you can just write the stage 1, right?
Yeah.
But if he asks you to show by backward induction, like in the quiz or the midterm, or whichever it was that he asked you to do it, you needed to write out both stages.
Yeah, but
So-
you have to write out on words, or can you just draw out both stages?
If you can make it very clear, because if he asks you to show backward induction, it's best to write it out. So if he asks you to show by backward induction, I would write it out like this.
Okay.
Right? Now if it's 3 stages, you go stage 3, player 1 offers this, player 2 accepts. Then stage 2, player 2 offers this, player 1 accepts. And then stage 3, that. And you say, this is my matched equilibrium because of these stages. That's how you do it. Okay. Any final questions while we're here? Are you guys' minds pretty much just melted at this point? 2 hours of studying is rough. I don't envy you. I'm about to go do it. Okay, if you have any questions on, I'll make sure, I should send that email right now. I'll make sure to get back to you as long as you guys don't email me
You're like beach.
Monday early afternoon because I'll be in a test, but I'll get back to you by Monday night. So you have until Monday night to ask me questions on the second exam or other questions. You can also email Dr. Carden.
You know Mitch Green? That's funny.
I'm not going to be holding an hour on Monday, so.
So that's
Just because he's my
section,
cousin.
that section, that's stage
Like,
3, right?
This is 2 stages.
Right, so what's that second one where it's at stage?
Yeah,
where the
yeah.
This is
player
stage
offers-
1, right? And if it was 3 stages, you could write stage 3 up here,
Ward, but I have no idea.
and you'd get, you're all conflicts.
I barely.
Offers 0, and P2 accepts. So P2 offers
See you, dude.
delta squared V, and player 1 accepts. So player 1 offers delta V minus delta squared V. What would you like to accept? That's the 3-stage one.
Got Bryce. Have to pick it out, man. What you know you should do is hit up your urban TA. Just get some
Dude, I just forgot your fucking Dude, you know what's funny? It's like that was like one of those weird blank moments because I've looked at your guys' assignments and like remember your names.
You got it?